So let's get over to the final part where we can finally make this autonomous. We have now a ball and it's rotating. Let's say you're able to rotate it by controlling its heading. And it's only using his actuators once colliding with the floor. So how about obstacles? So yeah, that is going to be an interesting part of it and definitely doable with at least the mechanics that I've implemented so far. So let's go to that part now. Very easily, if you want to know if something is the floor or not, is just to have some kind of if statement. We already have an if statement, so like if collision is the same as the ground ID, then do all of those actuator magic. But anything else is of course an obstacle. So if I put any more entities in the environment, like walls, yeah, it should be able to detect that as such, or detect that it's not something like the wall. So of course now there's no obstacles in there. So let's create another entity and we're going to add a white box and a white box collider. Yes, and then we also need to add a collider to it. White box collider. Use all kinds of blocks to create the wall. I can just select the entity, call it, I will call it wall. So if I play the game and the ball will actually hit it, we'll see it as an obstacle and it will constantly hit it because it's kind of stupid right now. So we want it to move away, but let's first make an arena. I'm going to make an arena first. So let's add this to a different location, this ball. Just again. Yeah, okay, so that's approximately an arena. Please it won't fall from the floor again. And it's able to detect that as well as the obstacle. Okay. So we would like to actually make it move away from the wall. So actually, the first bit of autonomy. Very simple, based on, if you look at robotics engineering in general, this is peanuts. But we still want it to work. So I add the property avoid angle for now, and that's not going away from, but with an angle, so it doesn't go and be ping pong from one wall to another. And then if you go to the part where it says, okay, yeah, it's an obstacle, then let's change the control heading to self, but to control heading plus self properties avoid angle. Yeah, okay, so interestingly is that it won't change the heading just yet, so it will just change the heading once it hits the floor again, because that's the control point. So it detects the obstacle and says, okay, let's go somewhere else. Yay, it's autonomous, finally. Very simple autonomy. This is like this type of autonomy they've already achieved. That was it again in the 20s, 30s, 40s. Yeah, when they had the turtle bots, and I don't think they ever had a bouncing Roboball, which will be cool to have in real life, I would say. The actual inspiration that I had was like one of those robotic toys for cats, where you actually have that can automatically rotate and play with the. But now it's going round and without any actual ball. So we would like to maybe add a ball. And also with the cleanup, we might have been a bit too quick with removing the tick. But I actually want it to now be aware of the goal angle, which is just position. So let's add the tick notification bus or tick bus back again. So let's activate self the tick notification bus, and on deactivate, they also have to close it again. So tick notification bus is next full, and then add the tick notification bus hashtag. Nice to have it here. Autonomous on delta time, current time, which I'm sure is going to be very useful for any other autonomy or state machine type of functionality if anybody wants to give a go on that. And then we're going to add a local goal vector, which is just going to be locally exposed into the scope of this function itself. 3 minus 5 minus 5 0. So it's like somewhere behind the ropes. And then the ball is there. Again, transform bus, remember that, to actually get position event, but get world translation, development identity, ID, comma, and then we have local, yeah, not two goal vector. I think it's not the vector. I would say that this is rather called pose, and then goal vector is pose minus. So it's apparently if you do a vector 3 minus another vector 3, it already automatically does the actual vector, not multiplication, but subtraction. So you don't have to do that per element, which is nice. Goal heading is then goal vector y, which is the this is actually what I found to be the a-tongus 2, which so that's kind of the simplifies it at least to calculate the angle based on the position, but also has the negation to that heading as well. So it's like in any direction. If that's like a regular A-tennis wouldn't work, and a regular A-tennis in Lua divided by A-tennis, but if you do comma, it's A-tennis 2. Good to know. Yeah, and then you want the control heading to be the goal heading. So the goal position is just an arbitrary position we get from transfer bus. The goal vector is the goal position minus the ball position. The goal heading is the A-tongus 2, which is the gamma. This one, the goal vector y and the goal vector x. And then you have the control heading is then the goal heading. Okay. So it should then now go behind it. Yeah, there you go. It's now going to a magic goal that doesn't exist. Well, that kind of looks weird. Let's add an entity to it. That's actually something that is all -5. -5. And we call it goal. Let's add a mesh to it. That's fine. And obviously we would also need to have a collider to that too. So just a simple primitive collider. And then because this is going to be a static rigid body, it's not going to be moving. So a collider always needs to be part also with a rigid body of physics, or else O3DE would be plain. As a box, I want to change this to a cylinder, and I want it to be a little bit higher as well, like 2. This is the radius. I would like to be 2 meters. So it's a little bit around the cone, so the ball will hit it a little bit sooner. But at least that is, at least that's it's able to hit it. So, and at least we're able to see it right now. But usually, like in gameplay, we have that the cone will actually disappear and will spawn somewhere else. So it would be nice to actually implement that for the goal too, because or else the ball will constantly go there and will just go there forever, and that's a little bit, we're not challenging the ball enough. So let's add a Lua script to the goal script, and also for editor, which was already open. We have to start a new script. Roboball goal, and then is spawn. Yes. And I've already prepared the script already before. That kind of does what I wanted to do. So let's just first show you what it actually does when I connect the script to the goal. If you look at the script right here, so this is the same rigid body notification handler, where on the physics enabled, it will actually start like an on collision begin, just like with the Roboball. And then it will say like, it's colliding, collision. And then you can bust on deactivate. So like, remember that on like these type of connections or like collision connections, anything that has to do with the physics engine, this needs to be enabled on physics enabled to connect it to actually the function on collision begin, which is not a standard function. On physics enabled is called when the physics are enabled in the game, which is just something to really keep in mind. But this is the script for the goal itself, and now it only screams collision, but we don't want it to only scream collision. We want it to actually move to a different part of the arena. So that means is that transform bus and set world X, so entity ID, which is the ID of the goal. And then I'm going to put a random number, random, minus 0.5, 20. Yes. So it's going to be like minus 10, 10 in the X direction that is going to spawn in. Let's just copy paste and be lazy and just do it for the Y axis itself. And yeah, so this will actually make the goal spawn whenever the ball hits it and go to a different location. So it should actually be a little bit further. But the ball doesn't know where the new location is because we hard-coded position in here. So let's change that. So yeah, then it means that, okay, let's remove this debug. For now, this is fine. I don't want to change anything to the goal spawn script, but we do want to change something to the Roboball autonomous script. So what I'm going to do is have another exposed properties called goal ID entity ID. Same thing as the ground ID. So I have to actually add the ground ID to the script now. So first I have to maybe play the game because it's a little bit... Usually when you have a Lua script, you just add a new exposed property, you won't see it. And now you see goal ID here. And I'm going to add the goal ID. So at least the Lua script of the Roboball knows which the goal ID is. And then on tick, which now has the function that actually keeps the heading of at least the heading towards or the bearing towards the goal in mind. We can now remove this hard-coded position, which is now, of course, after spawn, no longer valid. Transform cross event gets rolled translation vanzelf properties goal ID. Will this work? Probably. Okay. And it's now spawned over there. It's now spawned over. Oh, it missed it. Go back. There you go. I'm just going to cheat a bit and make the goal collider a little bit higher. So it won't constantly go over it because it doesn't have like very specific control that controls the direction of the ball whenever it hits the floor, which is not very precise. Yeah, there you go. Maybe it would be nice to have some kind of more of a nice things going on how you say. When it actually hits one of the cones, that you maybe have like a counter that counts down. But I guess we can program that in. We can use that at least from the debug log. Of course, like you can do like a canvas in front of the game to display that too, potentially. So then it means is that I just have to do like a self counter that is 0. And then we're going to have that in collision whenever it hits the anything else. But yeah, no, the counter then should be in the goal spawn, I would say, because that's actually detecting if it's colliding with something. It's not aware of where it's colliding with, but it's definitely colliding because it's floating above the floor, so it's never colliding with that. So I have the counter, and then you can have serpent counter is serpent counter +1. Maybe Lua has an easier way to do this, but this is fine. And then I can do log counter to string counter. Every time it hits, it should print out how many times it has hit it. So you can do score. Might be handy if you want to implement some kind of reinforcement learning type of environment or something like that. Talking about reinforcement learning, like we have walls, but we don't really have obstacles. So I think the next step is to actually add a couple obstacles, I would say. So same thing as before. Entity, add component, white box, and a white box collider. And then we can make it a little bit of a special shape. Make it high, and then we can select this. And then maybe special type, so we can maybe fool the ball in some other things. Doesn't have to be very complex behavior or a behavior like shape, but a shape. It needs to at least be some kind of obstacle added. Okay, I'm just going to copy paste this in a couple of places. First call it obstacle, and then select it, Control D, Control D, Control D, a whole bunch of them. A little bit here in the corner. I think it's going to be quite enough. Like I can probably rotate them slightly, but to not make it too difficult. Oh, so. Alright, so you have now the obstacles, you have the goal it's going to expose to it. It's a very simple logic it's right now using, so it's not... And now it's actually getting stuck. Interestingly. it's not the best of controller. But if you would imagine, this would be a nice example, at least for a reinforcement learning. So it needs to actually hit the goal, but avoid the obstacles. And I'm sure that it will be a way better type of controller than I've now hit, because it will only change its heading if it hits an obstacle, but it won't actually take into account if it was supposed to go towards the goal. But in this environment, that is definitely enough. But at least for more complex environments or an inside environment, that is going to be a tough thing to do. But yeah, obstacles can be a minus point for a reinforcement learning task. Hitting the goal would be a plus sign for a reinforcement learning task. So I can definitely see something that can be done here. So let's save and let's just enjoy this fact that I'm not controlling it. By the way, if you were wondering if I'm controlling it, I'm not. Yeah, so this is it.